Okay, this is group the tech ends. We are going to talk about the access control in Internet of Things nodes. Our group members are Raghu, Satyadeep, Shiva, Vanisha, and Vishu. We are going to talk about the introduction of the Internet of Things and Internet of Things architecture and IoT application, access control in IoT, access control models, access control challenges in IoT, and we will do the conclusion for this topic. So the Internet of Things is a recent technical advancement in the field of ubiquitous computing. The Internet of Things is described as a system of entities that exchange information and interact with the physical world by sensing, processing, and actuating. The Internet of Things offers innovative solutions to business and citizens that enhance people's quality of life and make a contribution to the global digital economy. So the adoption of IoT is steeply increasing and several IoT applications are emerging, ranging from smart home, patient monitoring, and industry domination to intelligent transportation, disaster management, and infrastructure monitoring. IoT security is one of the challenging issues that many researchers in various parts of the world are addressing these issues. As Internet of Things is a mix of many technologies, each technology has their own traditional security and privacy flaws, which are to be taken care of these devices. IoT integrates existing internet infrastructure with emerging technologies to ensure the seamless interconnection of hundreds of billions of embedded systems and control in the system, in the services they provide while lowering the cost of the internet infrastructure and making it more scalable, versatile, and responsive. While web services integration was an important addition to existing wireless sensor network technologies, so it also presented new challenges. IoT applications are typically installed in constrained source devices that only work up for a limited period of time, whereas web services are focused on long-lived transactions. While the Internet of Things has a number of advantages for individuals, business, and society, the use of resource-constrained devices and the introduction of a variety of technologies expand the attack surface and created new security vulnerabilities. Here we get to know the elements used in IoT are connected to each other. So I will introduce some IoT elements. An IoT framework is made up of computers or smart objects that can communicate with one another, and with the environment in order to provide services to end users. The components of an IoT structure will be referred to as nodes from now on. A communication interface is needed for a node to be used to communicate with other nodes. Every node, in particular, has a uniform resource identifier that uniquely identifies it across the network. Physical nodes, intermediate nodes, and device nodes are the three types of nodes we discern. The physical node may consist of a sensor, an actuator, tutor, or any other thing that can interact with the environment. A sensor is a system that senses changes the environment or detects events. Controlling a device or a machine is the job of an actor. Sensory and actual output is commonly referred to as resource. So here are the IoT elements.
Thank you, Shima. So now I'm going to start with the explanation of IoT architecture. Actually, it has many functional, it has many nodes. It consists of basically three nodes: application nodes, intermediate nodes, and physical nodes. The application nodes are the intermediate nodes and physical nodes. Okay. So there are many applications regarding this IoT devices. They are used in various sectors like homes, health sector, industrial sector. In health sector, they can be used as monitor. They can be used as monitor in the EEGs, which will be used for monitoring the heartbeat and pulse levels of the patient. And they are also used in detecting various diseases which are very potential to very potential threat to a person's life, like cancer and the cancer like cancer and heart blockages. So in home, they are used in various objects like doorbells, and even in the CC cameras, they can be used as motion sensor cameras. And even the smart TVs are smart. And in the industrial sector, it has various manufacturing options. Like in vehicle manufacturers, they are used to as alarm the people who are traveling in the car. If they don't wear a seatbelt, it will be giving beep sounds. And it can also be used to avoid the damage when there is some accident happening while we are traveling. Like immediately after the impact, the airbags will get opened. There are many access control modes in IoT devices, which are discretionary access control models, mandatory access control models, role-based access control models, organization-based access control models, attribute-based access control models, and usage controls. So among these models of access control, the most used are the discretionary access control model, role-based access control model, and mandatory access control model. These are the most widely recognized models which are used to control the access of IoT devices. And there will be many challenges in these IoT devices, like reusability of existing solutions. While access control mechanisms have been extensively researched and applied to an IoT infrastructure, they are complex and do not meet IoT specifications. Implementing and deploying and adopting a solution from the ground up requires time. And scalability. The number of connected devices is rapidly growing, which raises their management workload. In order to accommodate the growing number of IoT devices, a decentralized and distributed access control system must be provided. And heterogeneity. IoT infrastructure is distributed and consists of several heterogeneous interconnected devices that use various underlying technologies and come from a variety of disciplines. These technologies have different underlying authentication and authorization policies under each domain, which makes heterogeneity a major impediment to providing a scalable, stable, and safe IoT setting. And there will be resource constraints, like the computing and storage capabilities are limited in these devices. And whenever there is over usage or the usage crosses the limits which were predefined, we need to find a solution for those. So coming to the conclusion, there are several important requirements to support access control in IoT driven by the non-functional requirements to be met by IoT system. So decentralized methods are limited by delays, computational overheads, and energy constraints.